Hello everyone, today I'm going to talk about perovskite solar cells and how they are our future and what you can do to be involved in this. Let me begin right at the problem. As we all know, climate change is real. The planet is warming up and our energy resources are limited. Our dependence on conventional energy sources is not very sustainable, and current practices are leading to other negative effects like extinction of species. Because of how badly we're polluting the planet, we're giving birth to new diseases and a faster spread of those diseases. The quality of life is going down as our health is taking a hit. All of this is also going to impact the economy as our coastal areas are getting flooded and people's lives and our agricultural practices are getting disrupted. In short, we're kind of in a mess. Since we have established that we have a big problem at hand, let's take a look at what scientists and researchers from all over the world propose to be the solution. We need to reduce our carbon footprint, and the way to do that is by rapidly moving over to renewable energy resources. And in order to have renewable energy resources be a significant contributor in our energy demands, we all have to put our heads together and innovate new technology. In this regard, I want to introduce you to perovskite solar cells. Quite possibly the fastest growing solar technology, we currently have 27.3% efficient cells after just about a decade of work in this field. Scientists are terming this to be the next generation of photovoltaic materials, and rightly so, as these materials can be used to make up to 40% efficient cells when made in tandem with silicon cells or other perovskites. One of the very exciting aspects of this technology is the ease of manufacture. These are lightweight, flexible, thin films that can be deployed in rural areas. We can make semi-transparent and transparent devices out of them so that they can be used on tall skyscrapers. Because of how pretty we can make them to look, we don't need to hide them. We can use them to increase the aesthetic value of a building. The picture on your left shows you just that. Furthermore, they are really cheap to produce. They are made from a solution that is made from readily available cheap salts, and they can be printed roll to roll like newsprint. I think I have said enough to get you excited about this technology. Now let me show you how you can be a part of this. Your gateway into this new and exciting field of research is through iCons. iCons has brought together people from different backgrounds, and guess what? The field of perovskites has room for everyone. We need material scientists for understanding film morphologies, physicists for understanding the device physics, chemists to streamline the film fabrication process, engineers to build things, computer scientists and mathematicians for modeling behaviors and guiding us. In short, everyone brings something to this field. Since I've given you a brief overview of how everyone can get involved in this, I'm going to share my experience with you to give you an idea of how I got into this field. After my induction into icons, I chose the renewable energy track, and in our I2E class, we learned about the different renewable energy technologies, and that was the first time that I got exposed to the world of perovskites. I was fascinated by the technology and decided to do my summer internship on this. So the summer of my sophomore year, I went to India at the Indian Institute of Science and did a project on perovskite solar cells. This past October, I presented a poster on my work at the 4th International Conference on Perovskites and Optoelectronics at Lausanne, in Switzerland. And now, since I'm a senior, I'm applying to graduate programs in this field. But enough about me. Let's talk about how you can get involved in this as well. A great way to get involved in research is by getting into summer internships. There are several really cool internships that give you a lot of hands-on experience in working with this technology. For example, EPFL has their own summer internship opportunities, just like IISc does. I did my internship at IISc, but you can also go to Germany and pursue this with the DAAD RISE scholarships. If you'd really like to go to Switzerland, you could apply to the Think Swiss program as well. You could also stay in the States and still get involved in this. You ask how? NREL, the National Renewable Energy Lab, has some exciting opportunities too. If, however, you'd like to get a more in-depth experience, You can seek out Professor Venkatraman or Dr. Volodymyr, who are working on perovskites right at UMass. You can make use of the state-of-the-art facilities available to us at Conti at the Center for Electronic Materials and Devices. In summary, I'd just like to reiterate the fact that renewable energy resources are the future and perovskites are going to be a big part of it. So we all need to jump on the bandwagon now and collaborate so we can bring out the best in this. This can seem like a lot of information, but rest assured you have plenty of time and a lot of resources on campus to guide you through this. If you have any questions about how to get involved or about my work in general, feel free to email me at anveshasaha@umass.edu. I'd like to thank you for your patience and your time for listening to me. I'd also like to acknowledge Professor Sam Stranks from Cambridge University and Professor Henry Snaith from Oxford University for the images on the title slide and the perovskite wall slide. I also want to bring this to your notice that I am attaching all the links to the opportunities listed in the on how to get involved slide so you can make use of them. Thanks again and go solar!